Hey guys, in this video I'm inviting you to solve a problem on sequences and series. The sequence UR satisfies the recurrence relation UR equals AUR minus 1 plus BUR minus 2 for some numbers A and B. This kind of relation is called recurrence relation because each subsequent term is formed by adding the previous two terms with some coefficients. Let's say you can't form term 5 if you don't know the fourth and third terms. Okay, so we know the first, second, third, and fifth terms. They are 1, 2, 7, and 76 respectively. Now, in part A, we need to show that B equals 7 minus 2A, and find the quadratic equation satisfied by A. There's a little error here. Okay, and hence write down the two possible recurrence relations that can be satisfied by UR. Notice that the word hence in part B means that you need to use the result from part A in order to obtain the solution for part B. Sometimes you would also see the phrase hence or otherwise, which means you're free to either use the result of the previous calculation or solve the problem by any other method you like. Right then, let's get back to the problem. So part A is asking us to produce an expression that contains only A and B. It means that in the given recurrence relation, we must replace all of the u's by numbers. Now, we know that any recurrence relation starts with U1, U2, U3, and so on. But we can't start with R equals 1 in this particular problem, because if we substitute 1 for R, then the second term of this recurrence relation will be U minus 1. And of course, that doesn't make sense. So if we now inspect the relation, then it's clear that we must start with R being equal to at least 3 so that we get U1 in the second term. So let's write it down. R equals 3. So we can now form the third term of the sequence. U3 equals A times U2, right? We plugged 3 in here, plus B U1. Okay, let's now see if we can substitute the numbers in and see if we can get anything meaningful. So U3 is 7 equals A times U2, that's 2A, plus BU1 plus B. So now you can see that it looks very similar to the required expression. All we need to do is to express B in terms of 2A and 7. And that is B equals 7 minus 2A. Okay, the first task is done. Now we need to find a quadratic equation satisfied by A. That sounds pretty tricky. Let's have a look at what's given again. We have U1, U2, U3 that we've just used, and we have the fifth term, 76. So let's now work with it and see if we can get anything meaningful. U5 means that R equals 5. So U5 equals 76. I'll write here R equals 5. And it means that the expression becomes A times U4 plus B times U3, 5 minus 2. Okay, so we have the term U3, but we don't have the term U4, right? And that's the term that we need to produce, again using the same recurrence relation. Let's do that. So U4 equals A U3 plus B U2. And the next step is to substitute this term back into the expression for U5. So it follows then that U5 equals 76, and it is equivalent to A times AU3 plus BU2 plus BU3. Right, so now we can see that all of the U's can definitely be replaced by numbers. So you could open the brackets now and then substitute the numbers, or you could leave the expression as it is and plug the U2 and the U3 in this expression. Let's do that. That's the same as A times 7A plus 2B, right? Remember that U2 equals 2 plus 7B. Okay, now we have the expression in terms of A and B, but we need to form a quadratic equation satisfied by A, so we have to get rid of B. And remember, we have just shown that B equals 7 minus 2A. So we are going to substitute B equals 7 minus 2A into the expression for U5. This gives us 76 equals A times 7A plus 2 times 7 minus 2A plus 7 times B, 7 minus 2A. Okay, so now our job is to open the brackets and to simplify the expression. So on the left-hand side, I've got 76 still. Now on the right-hand side, I've got 7A squared plus 14A. You can see that we need to multiply this bracket by 2 and by A. So 7 times 2 times A gives us 14A. And then we have minus 4A squared plus second bracket gives us 49 minus 14A. Okay, so 14A and minus 14A would cancel out. 7A minus 4A squared gives us 3A squared. And if we take 49 to the left-hand side, that would give us 76 minus 49, which is 27. Now, if we divide both sides by 3, we obtain the quadratic equation in terms of A. A squared equals 9. Okay, so part A is now fully complete. Let's now proceed to part B. Hence, write down the two possible recurrence relations that can be satisfied by UR. What it means is that we need to substitute the numerical values for A and B into the given recurrence relation. So we have two possibilities for A from part A. Let's write them down. From A can be equal to 3 or minus 3. When A equals 3, B equals 7 minus 2A. This is 7 minus 2 times 3 equals 1. So the first recurrence relation is given by UR equals 3 UR minus 1 plus UR minus 2. In case when A equals negative 3, B equals 7 minus 2 times minus 3. That's 7 plus 6 equals 13. And it follows then that the recurrence relation is minus 3UR minus 1 plus 13UR minus 2. Okay, that's done.